Hey everybody, welcome back. Mr. Smith here. I want to talk to you in a little bit of a different way before we start the slide deck. What I'm going to outline in the very short deck we're going to do today is the key to you getting good results all year long in physics. If you're willing to take on the strategy that I suggest here and you work with it, you're going to find that you can crack really hard problems and that you're going to improve your organization and your ability to do math in a really clear way, in a way that enables you to convince other people that you know what's going on and that you can get them from the beginning to the middle to the end of a problem. So what we do at St. John's is we teach a method for problem solving that we call LEPS. And what LEPS stands for is really simple. L is list, E is equation, P is plug in, and S is solve. And the way we want you to do the work is the way we're going to grade it. List means make a list of the variables. Sometimes with the easy problems like we're going to do in this deck, you could probably do them without doing this method. But we're starting you slow and with easy problems because we want you to get used to this method. And we don't want to throw everybody in at the deep end immediately. But sometimes the list in physics can be 7 or 8 variables long, and that's a lot. So we want you to be organized. Second thing is equation. You're going to write down the equation that you're going to work with, and then if you need to do algebra, you do it. Third thing is we're going to have you plug in the numbers with the labels on them into the equation that you just solved. And then finally, go ahead and grab the calculator and then make sure you write down the answer with actual labels. So what does it look like in real practice? Here's a simple example. We've got a Honda Accord, is the most common car in Massachusetts. And at highway speeds, it can drive around 30 meters per second. So when I look at 30 meters per second, I notice that that's a velocity. A student drives from Lawrence to Danvers on the highway, a distance of 15 kilometers. I look at that and I notice that's a distance. And so how long does the drive take? So my list for constant velocity problems is going to be like this: D, V, and T. And what I'm going to do is just write down everything that I've got from my list. So D is 15 kilometers. Velocity they gave us was 30 meters per second. And now my list is done. The list is the place where if you have to do metric conversions, you can do them. So I've got a mismatch. Kilometers is not a standard unit, and meters per second is. So what I'm going to do is right here, I could do this in super simple mode and just blow out the km and put in times 10 to the 3. Or I could write, there's 1,000 meters in 1 kilometer and work it this way. And we're going to end up with 15,000 meters of distance being covered. And my list is done. So I've got everything in standard form, that we're good to go. Okay, next thing I'm going to do is E. I'm going to write down the equation. So the standard velocity equation for constant speed is just D equals VT. And what I'm going to do now is part 2 of that. I'm going to solve this thing for T. So I just show everybody, hey, I'm doing the algebra. T equals D over V. That step is done. The equation step is done. Finally, what I'm going to do is just plug in and solve. And plug in for this one means just take the equation I wrote and fill it full of numbers. So 15,000 meters over 30 meters per second. And see what I did? I wrote them with labels. Finally, I'm going to go ahead and solve for that, and the answer turns out to be 500 seconds. And that is going to get it done. So I wrote down the answer with labels. You're good to go. If they made this a problem a bigger deal, you might have to go down and take your list and say 500 seconds, and they might make you do the work of converting that to minutes or something like that. But they didn't say anything here. We're going to leave it. It's 500 seconds. We're good to go. Okay. One more example, and then we're good to go and talk about this in class. In this one, distracted driving has been, good news has been on the decrease for about the last 10 years. People in the 15 or 16 to 25 age bracket are still some of the prime offenders for doing it. And in 2018, distracted driving, so eating, looking around in the car, being on the phone, was responsible for about 10% of highway fatalities. So it's not as high as drunk driving, but it's still pretty high. Anyway, in this question, if you look away from the road for 4 seconds, the question is how far will your car go? All you're going to do with this one, same thing. mark this down. If you see meters per second, that's a V. If you see 4 seconds, you know that's a T. So what I'm going to do in a constant velocity problem is just write down my 3 variables, d, v, and t, record what they gave us. So v was 30 meters per second, and t was 4 seconds. And in this one, when I write down the equation for my second step, it looks to me like, when I look over at my list, like everything's in standard form. They're just asking for d, so I don't have to do any algebra in this one. So this is super simple. I'm just going to go ahead and plug in 30 meters per second. And notice how the seconds cancel against what I wrote. And I'm going to end up with 120 meters of distance covered. So list the variables, E, write down the equation, P, plug in with labels on, and S, solve. That's the system we want you to use all year long. That's the way we're going to grade them. I hope you really take it to heart and you really work with it, because it's going to be the key to you getting good results all year long in physics. Thanks for watching. We'll see you in class and we'll work with this. Take care. Bye-bye.